So this table is going to help us model equations for the Ferris wheel. And we're going to go through this and talk about where each of the numbers go. Now I've already wrote in our basic form of the equation, and you'll want to copy this down. So we've got y equals r times the sine of t plus the start height at 3 o'clock. So r is going to represent our radius, and then t is going to represent your period. And of course the start height at 3 o'clock. Now this is important because all of these applies to when your start height is at the 3 o'clock position. Now, for this particular table, we are not going to worry about this column or this column right now. We'll worry about these on our next table, okay? So I'm going to zoom in a little bit here, and we're just going to worry about these columns for right now, okay? So when starting writing our equation, your radius is going to go out front. So in our first one, our radius is 25. So we can go ahead and do that, and we can go ahead and put the t here. Now, the start height for the 3 o'clock position. So this is where your picture is going to help. So if you think about it, when you sketch it out, if you have your Ferris wheel, so kind of think about, you've got your Ferris wheel here. So your radius from here out to the center, this particular Ferris wheel has a radius of 25, okay? Now, it also tells us that our wheel, if we look right here, our wheel is 5 meters off the ground. So from here to here, here's the ground. This is 5 meters off the ground. And if our radius is 25, so keep in mind from here to here is 25, 25 plus 5, this gives us a total distance of 30. So our height at the start at the 3 o'clock position is going to be 30. So we're going to put a 30 right here. Now, for all of these, our period, the time required to complete a trip around. So like if your little seat is going to start right here and you're going to go all the way around the Ferris wheel, our period is going to be 2 pi. So that's what it would be on the graph. So that's what it's going to be for all of these. So that's how we do the first one. All right, so for the second one, if we start off, we can go ahead and put 20 sine of t. All right, if we draw our little sketch here of our Ferris wheel, we know that our radius is 20, and we know that the height off the ground from here to here is 10. So 20 plus 10 is also going to be 30. So we're going to put plus 30 here. And our period is still going to be 2 pi. And these are in meters. Okay. So then for our next one, we have 7 sine of t. So for our Ferris wheel, so we know out to here, so here's the center, out to our radius is 7. So the height off the ground, it tells us, is 3. So our total distance, 7 plus 3 is 10. So that will be 10 meters. So we put plus 10 in our equation. Now, we got to add our 2 pi over here. Now in this one, it wants us to figure out what our radius is, our height, how far the wheel is off the ground. Of course, we know our period is still going to be 2 pi because right here we just have a t. So looking at the number out front, that tells us our radius is 25. So if I go ahead and sketch my Ferris wheel, I know from here to here, my radius is 25. Now, if my total is 35, because total height off the ground is 35, remember, here to here is 25, so what plus 25 equals 35? And that would have to be 10. So I would plug in this box, 10 meters. Okay, so moving on. Very similar, except this time, notice we don't have just a T anymore. We're actually gonna have to figure out what our period is, okay? So the first thing that we'll plug in, that we'll figure out, the easiest thing to figure out, is our radius, which is gonna be 15 meters. If we draw our sketch, because it always helps to visualize. Okay, so we know our radius is 15. We know the total height is 17, and we know it's 17 meters off the ground. And this time we're actually going to fill in the entire table. All right, so what plus 17 is going to give me, or what plus 15 is going to give me 17? So this right here, this distance has to be 2. So it is, oh, I got my number switched here. This should be 17, and this should be 2 meters. Now, to figure out your period, it's always going to be 2 pi divided by whatever your number is with t. So 2 pi divided by 0.5. We're going to leave this in terms of pi. So that's going to be 4 pi. So if we do a speed comparison compared to like our original, so where your original was just t, you're taking more time because you're comparing it to 2 pi. So it was taking 2 pi seconds, we'll say. If it was taking 2 pi seconds, now it's taking 4 pi seconds, then we would say it's going slower, okay? So it's now going half as fast, and it's double the time, okay? So it's half as fast, okay? It's not going as fast anymore because it's slowed down, so it's half as fast because 0.5 is half, but it's double the time because we went from 2 pi to 4 pi. Okay, so on our next one here, we know that 24 meters is our radius. If I draw my picture, from here to here I know is 24. My total height is 27. So I know I have to add 3 to get to 27. So I know my wheel is 3 meters off the ground, and my height, my total height is 27 meters. So the period, the time required to complete a trip around, I'm going to take that 2 pi and divide by 2, which is just going to equal pi, okay? So the 2 here means it's going twice as fast because you're doubling. And for the time, it is now taking half the time because we got to describe it in talking about speed, and we are describing it as far as time, okay? So as far as the 2, in terms of speed, we're going twice as fast. So the 2 means we're going twice as fast. We're taking half the time. It's taking less time. Okay, so if you want to, feel free to pause it and maybe try this next one on your own. So 12 meters is your radius. When you draw your Ferris wheel, of course the radius is 12. Your total height is 13, which means from here to here is 1. So the wheel is 1 meter off the ground. And of course your starting height, or your height at the 3 o'clock position, is 13 meters. So we're going to do 2 pi divided by 1.5. And we want that in a fraction, so we would just do 2 divided by 1.5. We're going to leave our answer in terms of pi. So that is going to be 4 pi over 3. Okay, so in terms of speed, we're going 1.5 times as fast. Okay, because we've gotten faster, and we're only taking 2/3 of the time. Okay, because it's going to take less time. When you go faster, you take less time. Okay, so looking at this one, your radius, you got to be careful on this one. Your radius is still 12. Your radius is not negative 12. Your radius is a distance. All this negative means, so before, remember in the beginning we said that we were rotating counterclockwise. So what this negative means is that we are rotating clockwise. We just changed direction. So that's what the negative means. It just changes the rotation of it changes the direction of the rotation. So my picture is still going to be the same. All right, my radius is still 12. My total height is 14. My distance off the ground, that would be a 2. Okay, so now when I divide, I would do 2 pi divided by 1, because my t here is just 1, so that's just 2 pi. And this time there was no change. This is going to stay the same. The speed stayed the same. The time stayed the same. Okay, on this one, my radius is 5. When I do my picture, so 5 is going to go here. My total height is 7. Off the ground here is 2. All right, so now I'm going to do 2 pi divided by 3. So it's just 2 pi divided by 3. So this time it's going 3 times as fast, which means it's taking 1/3 of the time. Okay, it's going faster, so it's going to take less time. Okay, so now this one we have to describe in terms of variables. Okay, so our radius is A. So if you think about this, this would just be A. Our total height here is C. And remember when we found the distance, what I did is I did my total height, which was C minus A, to get that part right there. Okay, so C minus A is what we say for that. So the height at the 3 o'clock position was just C. And since B is with T, this time I'm going to do 2 pi over B. And notice each time, whatever that number was, that's what we said that it's that times as fast. So we would say B times as fast, because that's what we did in every previous problem. Whatever that number was with T, that's how fast it was, or like that was our multiplier. And then for the time comparison, that was, we said like if it was 3 times as fast, it took 1/3 of the time. Or if it was twice as fast, it was half of the time. So we're going to turn that into a fraction. 1 over B of the time. And that's how you would do it with variables.